Hi, this is Jenny, and this is my video experiment report for Experiment 1 in Physics 2212. So, introduction. The purpose of the experiment is to observe the interactions of charged tape with other objects, and also we determine the magnitude of charge generated on the tape. There are three main results of the experiment. So first, tapes are positively charged. And also, by the calculation, we get that the magnitude of the charge generated on the tape is approximately 2.583 times 10 to the negative 8th. And we also got that the number of electrons transferred between the tape is approximately 614 times 10 to the 11th. So the image above shows some basic concept for the experiment. When we put two charged tapes close to each other, they repel, and with some measured value and equations, we can get the quantity of charge on the tape. We have some initial conditions listed, like the length and the width of the tape, and with those values, we can get the mass of the tape. We make some assumptions, like the air resistance is eligible, and also we assume that each tape has the same net charge. In this experiment, the system is tape B, while the surrounding is tape A and the Earth. So the main physics idea of this experiment is that by rubbing, touching, or pulling apart two objects, they may acquire charges while electrons transfer from an object to another. We will use three equations in this experiment. So first, F equals to mg, second, F equals to k times q1 q2 over r squared, and also F equals to qe. The free body diagram shows how we are going to solve this problem. So since the tape B is at rest, we can conclude that the force in y direction is 0, which also means that the upward electric force is equal to the downward gravitational force. So before we do the experiment, we need to do some prep work, like make a charge tape. To make a charge tape, according to the instruction, we need to have a base tape, and we put the U-tape with a handle on top of a base tape. Then we pull the U-tape apart from the base tape with a really quick motion, then we get a charge tape. So with the charge tape, we can do a few experiments and have some few observations, and which leads to some conclusions. There are two conclusions that are quite important. So the first one is two tapes have like sign. This is from the experiment that when I put two charged tape close to each other, they repel. And we also conclude that the tape is positively charged because it is attracted to the negatively charged plastic ruler. So in the second part of the experiment, we do some measurements and calculations. So first we measure the distance between the two charged tapes, and we also have the mass of the tape. Then we can plug those values directly into the equation mg equals to kq squared over r squared. Then we get the magnitude of the total charge on one tape. With the total charge, we can also get the number of deficient electrons. So those values are all mentioned at the beginning. So with the number of electrons, we can also calculate the percentage of atoms that lost electrons. We have the area of the tape, we have the area of the atom. We can get the number of atoms in the tapes, which is 1.25 times 10 of 19th. Then we use the number of electrons over the number of atoms, then we can get the percentage. So after doing the physical model, we can do the computational model. In this model, we assume that the charge in the tape can count as a point charge in the middle of the tape. So the two blue dots are tape B and tape A, and the orange arrows are upward electric force and downward gravitational force. The computation and the result in this coding is exactly the same as what I did above, so I will not repeat myself. So in the second model, we assume that the charge in the tape is evenly spread on the surface. The red dots are the particles in tape B, while the blue dots are particles in tape A. The green arrows are the representative of electric field, while the white arrow and yellow arrow are upward electric force and downward gravitational force. We got the exact same magnitude of gravitational force as the last one, but the magnitude of electric force for this model is much smaller than the previous model, and I will explain why later. So what if and why? If the electron is positive and the proton is negative, both tapes will be negatively charged, and they will still repel against each other, and they will also repel the negatively charged plastic ruler, which is different from our previous result. And the reason that Q value for the first computational model is much larger than the second one is that in the second model, some of the electric force can be decomposed into forces in horizontal directions, which will cancel out eventually. This model should be closer to the real value since in real life, charge should be evenly spread on the surface. There are some possible sources of error, like there might be bias when we're calculating the mass or measuring the length and width of the tape. And if the charge are not evenly spread among the surface of the tape, or there are loss of charge during the experiment, there will also be errors.